Okay, hello and good morning. We're in week 1A, which is the first full week, and I wanted you to write the sign numbers here, or the rules for the sign numbers. Okay, don't forget that your math fees are due by Friday, and remember that your homeroom stuff is due to your fourth period teacher today. Let's take a look here. If you have the same signs, and Friday you're going to have a quiz on these 4 rules, so make sure you know. Same signs you're going to add and keep the sign. 2 things. 1, 2, keep sign. Okay? Rule number 2 is opposite signs. You're going to subtract and keep the sign you have more of. If you have more negatives, then you're going to end up with a negative. When you multiply or divide, same signs will be a positive and opposite signs will be a negative. And those are the 4 rules, and you're going to have to write those on Friday. Okay, so memorize them, and they will only help you. All right, so let's keep moving. Down here, we're going to use the rules. However, here we're multiplying. So we have the same signs. 2 negatives is going to be a positive. 3 times 2 is 6. This is 1 negative. If it's 1 negative, it's going to be a negative. This one right here now, it's minus. So this sign is the same as this one, but that's going to be rule number 1. So you got to add these and keep the sign. This one right here changes to a negative times a negative. That's 2 negatives. Now the signs are opposite, and opposite signs you have to subtract. So 3 minus 2 is 1, but you have more negatives. And that's how you do that. Make sure you understand that. All right, today we're going to talk about some geometry. Now let's take a look here. We're going into the workbook, and I'm going to see about getting your workbooks sometime this week, maybe as soon as tomorrow. So let's take a look here. We're going to actually measure angles today. So you have 2 sides here. This right here is called a protractor. And I don't know if you can see it, but that little mark right there is what you're going to put on the vertex. Okay? And on this one right here, the little mark, I guess, is right here. Okay, let me look at that and make sure. Yes, it's going to be right there. Sometimes they have a hole, and I don't have one like that. I'm going to use this one right here, so watch how I measure this angle. And by the way, we have some definitions here, so let's just go over that first. So on a new sheet of paper, put away your bell work. I want you to put 1.1 and put notes, and then put today's date, which is 8/17. So we have acute, angle, obtuse, angle, and a right angle. Well, an acute angle is anything in between 0 and 90 degrees. So if the angle is inside this range here, so between 0 and 90 degrees. A right angle is a 90-degree angle. So a right angle looks like this. Okay, so if you build something, you want it to be a right angle. An obtuse angle is bigger than 90 degrees. Okay, so there's 90 degrees. So there's 180. So an obtuse is between 90 degrees and 180 degrees. Okay? If it equals 180, it's called a straight angle. So a straight angle equals 180 degrees, and that's going to be a line. Okay, so write that down and make sure you understand these definitions. Okay, so let's take a look. Getting back to the protractor. All right, and these are numbered, so please don't take them out of the room. That's going to be your vertex. So right here, put vertex on your paper, and then line it up in the middle. Now look, you're going to swivel this edge here to line up with this bottom edge. Okay, so the dot has to go on the vertex, and this edge has to go on your initial side, which is that one right there. And if you look here, it's kind of hard to read. You don't want to do 110, and I might even have this upside down. So let me flip it over. Okay, that looks a little better. I mean, if you can't read the numbers, make sure you swivel it. This one looks like 45 degrees. 10, 20, 30, 40. It looks like 45 degrees. So I'm going to say 45 degrees on number 1. And since it's between 0 and 90, it's acute. All right, I'm going to do one more with you. So watch what I do. Take your protractor, put the dot on the vertex, and then swivel the edge. So there's the dot. Swivel the edge until it lines up with the initial side. Once it's lined up, start counting. 10, 20, 30, 40, 50. It looks like 120. So I'm going to go with 120 degrees on this one, and this one is obtuse. Now we might need to share protractors today. You're going to do the front and the back, and when you're done, see if someone next to you needs a protractor, okay? If you happen to get something like this, you're going to do it the same way. You're going to put that dot or that mark, and then you're going to swivel it until this side lines up right there. And then you're going to start counting. 0, don't count here because that's too much. 0, 10, 20, 30. And again, it looks like I'm upside down, so we'll flip it. Okay, so this looks like 45 degrees right here. All right. That's how you do that first page today. And then there's a second page. All right? So we're going to talk about some of these. So look up here and listen. It says, how are properties of segments and angles used to determine their measure? Well, there's something called angle addition postulate and segment addition postulate. And what you do is you basically add stuff up to equal the whole thing. Okay, so add up to equal the whole thing. So just copy that down. I'll give you number 1. There's going to be some of them where I'm going to have to tell you what they are. And so there it is. All right, let's keep moving. All right, next. This one right here says error analysis. This is the absolute value. All you do for distance, which is what they're doing here, is you count the spaces. So watch what I do. 1, 2, 3, 4, 5, 6 is the spaces. And that's what that is. So really, the way you're going to do this, and I want you to write this down, distance, you can either count the spaces, or you can take the big number minus the small number. And that's the way I want you to really do it. You can count as well. The big number is 5 minus the small number, but look, it's a negative, so it's going to be 5 minus, and then it's going to be a -1. So that's going to be a double negative, which gives you 6. And again, you can verify it by counting your spaces. So it's big number minus small number. What does it mean to be congruent? Write this down. This is a definition. Congruent means the same measure or equal. Equal or same measure. Okay, so there you have it. Equal or the same measure. You need this? All right, making sense of it. It says in preserve, suppose M is a point, yes ma'am. Suppose M is in the interior of angle JKL. Well, you have to know how to draw an angle here, and I'm going to show you, so watch and listen. We're going to put a dot here, okay? And then you're going to draw a ray, which is what that is right there. And then you're going to put another ray, like that, okay? And you're going to label it. See how it says JKL? So you're going to put JKL. And so now that we have it labeled, it says that M is in the midpoint or somewhere in the interior. This up in this region right here is called the interior. So put a point right there and call it M. And it says, suppose that angle MKL is 42. So here's M right here. K, and L. So this angle, suppose this angle is 42 degrees. Okay, I need you to draw this. And the measure of JKL, so JKL is the whole thing. Let me use a different color to show you this. So JKL is from here to here. The question is, what's the measure of JKM? Okay, so what you're going to do is subtract here. So you're going to take the whole thing, which they told you was 84. So the whole thing is 84 minus 42 degrees, and whatever you get is your answer. So start bringing a calculator so you can do that. And this is called angle addition postulate, and we're actually subtracting here. So we're using the subtraction property. All right, let's keep moving. These right here, you can just figure them out on your own. You just count how far it is. I think that's halfway, so I'm going to say this one is 1. Okay, now watch this one. Collinear is another word you need to learn today, so write this down. Collinear. Okay, and I'm going to stop talking in just a minute. Collinear means in a straight line. Write that down. This is a very important word. So look here. If I put these dots like this, like if you see mama duck and baby duck, they walk in a straight line, that would be collinear. If the points are not on a straight line, like this point is not on it, then these are called non-collinear. Okay, make sure you know that. Collinear is mama duck and baby duck. You can try this one on your own because it works similar to that one. And then flip it over and try and work these as well. Okay? So that's your assignment for today. If you get stuck, I need you to try, okay? All right, let me switch now to MCR. With MCR, I want you to copy this right here. Okay? So these are all your numbers here. And we're going to write them down. So let's talk about that a minute. All right? So you have real numbers, which is denoted like this, with a big fancy R. And then from there you have irrational numbers, like pi. So irrational numbers, and you should be writing this down, all right, they go on forever, and they do not repeat. Write that down. And you got to memorize this, okay? These are numbers classification. Let me move this over a little bit so you can see it. In fact, let me make it a little smaller so I can get more of a range here, okay? All right. So once I get to this point, now I go to rational numbers. Okay, so rational numbers repeat or terminate. Okay, so if it goes on forever, it's going to be irrational. And I think I might have lost focus there, so let me see if we can get focus. Okay, so that should be better. A rational number repeats or goes on forever. So let's keep moving here. There's something called natural numbers, and we're going to write that down. So put natural numbers. Natural numbers start off with 1. There's no 0. Okay? Whole numbers, which is the second one, start off with 0. Okay, that's the only difference between these two. Integers are going to be your whole numbers and natural numbers plus your negatives. So that's going to go ... -3. So copy this down, 1, 2, 3, ... Notice there's no decimals here. Your rational numbers okay, are going to be anything that terminates, like 3.4 stops. Or anything that repeats, 3.474747. Okay? All right. And anything you can write as a fraction. So if you can write it as a fraction, it is rational. Like all of these are rational numbers because I can write it as a fraction, like 3/1. Okay? And there it is. There is all the numbers that you need to know. Today, you're working on this worksheet right here. And this is a lot of work. So at least give me the front side here. Okay, so give me 17 through 74. So 17 through 74 today, and we'll pick up on the other one tomorrow. Have a good morning, and I'll see you in class.